thank you very much for welcoming me. It's a really great pleasure. I come once a month, roughly, to India, and it's really a great honor to speak in front of you and share humbly a bit of our journey in nuclear, which has been lasting for more than 50 years in EDF, and which we expect to continue for many decades. I'm sure you've shared here all the positive perception of nuclear, which is back in the game now, in the center of the game with the COP28. And so I think we all have to play a big part in this, and we look forward to getting India accelerating and showing the world how fast and great nuclear can be for the future of this country. So maybe you've been very kind, sir, in saying that EDF doesn't need introduction. Still, I will maybe explain where we come from. Today, EDF is, as a single company, the world's largest operator. I think probably in some years will be overtaken by some big Chinese company. That is to be expected. But say so far, we are the largest world operator as a single entity. We've got 56 reactors in operation in France, 9 reactors currently in operation in the UK, and we do contribute to the operation of 2 reactors in China. We count our experience, just like we all do, in terms of reactor year. So we multiply the number of reactor by the number of years of operation, and that gives us more than 2,000 reactor year of experience, which means that a country like the Netherlands, which have 1 power plant, it will take them 2,000 years of operation of that single plant to get to the same level of experience. That is not to compare, that essentially to say how much there is to learn. And you probably know, we have been through very difficult phases and experience last year with our fleet. And I think this is a reminder that whichever stage and maturity of development you are in, nuclear is humbling as a whole. So we are present with all this experience in design, build, operate, and decommissioning today. So we are present in the full value chain of nuclear. How did we get there? It's been long history, and I think it's best pictured by this graph. We started in the 70s based on two things happened. There was the oil shock. France is actually geographically a pretty small country and didn't have any natural resource. So the government had to take dramatic action, and they took one bold decision to build significantly nuclear capacity in France. It started with Fessenheim for 2 900 megawatt reactor, and then we had 32 additional reactors of the same kind being built in France. It's fair to say that these decisions were made before having a clear decision on how much it would cost and how much capability we had to mobilize. This is a very important element. So the one thing, and I was sharing with my good friend Mr. Arun Naik earlier, one big difference I would say between France and India is that the decision-making process involves a go decision before you have all the parameters of the program. This is true also today. As we launch a 6 EPR program, the decision is made before we have all the full cost and all. But the industry then gets prepared and comes up with a full proposal aiming to be the most economical at the end of the day. In India, there is a logic to challenge the industry through the process and then make a decision Comparably, through this process, we get to a significant number of reactors built in France. Comparatively, let's say, maybe India could look at other ways and other processes. This is just food for thought for the rest of the journey. In our journey, beyond building 58 reactors in France, we have been also supporting other partner countries developing themselves. We have South Africa. That's I'm checking whether point. Oops. This is the pointer. Yeah. So here, in the 80s, end of 70s, 80s, we've supported South Africa build its first reactor, and a couple of those reactors have been built. These are the replica. Actually, they are cousin reactors of what we have built in France at a site called Dayabé. We have also supported the Korean industry, Shinanul reactors, and we have actually been at the origin of what is today a very buoyant and successful industry in China, with Dayabé as a first pair of reactor, which is just opposite of Hong Kong, and actually it was meant to deliver power to Hong Kong. Today, this is where we are. We are entering into the third generation phase with our EPR reactors, and in France as well as in many other countries, we're aiming to accelerate growth. Generation 3 has its specific difficulties, complexities, and requires a lot more projects to ensure that costs can be improved. We are, I would say humbly, at the beginning of this journey, not even in the middle, but we have great hopes to improve this situation. This is what we have achieved so far. I would say not easily. So we have our own scars on many of scars on these programs, but we have completed the Taishan program in China, and we have successful operations for 2 reactors, EPR reactors of generation 3 plus today. Both of them are up and running nowadays. Finland, Olkiluoto 3, finally now is up and running. It's difficult to compare the situation. This was meant to be a single unit, not a twin unit, which in its own right is part of our lesson learned. Would avoid trying to have single unit programs, actually, but rather encourage at least twins and even more to have a significant program effect. And Olkiluoto today is providing 15% of Finland's electricity. For those who don't know Finland, Finland is a very industrial country with a lot of high power intensity, power savvy industries like paper, like also metal and all other related industries. In France, we are very soon to complete the Flamanville 3 EPR program. This was another single unit program which we definitely don't want to replicate. We're going to go for series. So here in France, there are 3 reactors on the site. These 2 are 100-watt reactors of generation 2, and Flamanville 3 is here. This is the generation 3 plus reactor. We expect to fuel load early next year and get into commercial operation in the course of next year. What you see here is a picture. Actually, this dates almost a year of Hinkley Point C, which is the construction of a twin EPR in the UK. What you see in this picture is the liner being installed through actually the biggest crane in the world, which we have installed there, which we call by its nickname Big Carl. You can see it in yellow here. In this project, we have performed a lot of prefabrication through our experience learning. I will come back to that, which has allowed us to accelerate, actually completely integrate lessons learned from previous program and accelerate construction. I don't have the picture here today, but we are to put the dome by the end of this year. So this is in a few days. The dome of the reactor will be up there. So that's to give you a picture of who we are and where we are today in generation. Now, of course, the objective to get, because this is the theme of the presentation, how to grow, reduce cost, do it successfully, repeat. So, two aspects I'm going to develop in the next section. One is related to the benefit of the series effect, how important it is to have visibility on a program to be able to plan and ensure that things can improve over time. And second, of course, to make sure that this happens, specific process related to lessons learned. So, a bit of the theory which is verified by experience. So this is the curve of how things basically have evolved in France, and how basically we've seen the construction cost evolving over time. So, of course, what you can see here is a progressive increase, but at the same time, what you can see that this is there's quite a lot of variability, and also it's not linear, and you manage to actually get to a point where things can be fully put under control. Now, why does this go up? Is because we're moving from generation 1 to generation 2, and eventually the level of complexity increases significantly. But the reason we managed to get some improvements in the numbers and the learning is that first we make sure that we benefit from what we call program effect. So we plan as a program, we can procure as a program, we can leverage engineering and developments across a fleet, and secondly, of course, there is learning through productivity, and this is something which I would say would be by the book, something that you would see everywhere. Maybe some concrete numbers. If you look at the program effect, and we now consider the program not on a single country basis, but on a worldwide basis, we look at that, and when we compare Olkiluoto 3, which is the first EPR which started construction with Taishan, actually we've been able to cut the number of engineering hours 60%. This is the capability of using a number of detailed design elements in the drawings of Taishan. Manufacturing itself as well, Olkiluoto 3 could be considered the first of a kind. And when you look at steam generator manufacturing, we have been able to cut the manufacturing duration by 2 years from one program to another. And this is important in the sense that, bear in mind, this is just the beginning of the journey. We're very far from having fully industrialized all these processes. The reason why is currently, when you look at the different EPR programs, the first EPR was decided for Olkiluoto in 2004. The second then for Flamanville was decided in 2004, but the pouring of the concrete was in 2007. And Taishan was decided in 2009 and pouring of the concrete the same year. Then we had a huge gap, and we had to wait until 2016 to have Hinkley Point C decided. And so those significant gaps didn't allow really the industry to fully organize itself. So lessons learned have been happening, and we can show these numbers, these figures, but we don't have the full effect of those yet. And this is why, considering the future of the nuclear program in France, we're encouraging the government, and the government has decided to make a 6 EPR program decision in one go, and that was decided in February 2022. I'll come back to that. Series effect, other examples, replicating the design. This is going to happen in the UK. So the Hinkley Point C design, for which I've shown a couple of pictures, that design is going to be replicated exactly at Sizewell C. Because the UK has its specificities, it's got specific design elements, just like India ERB is requesting some, or say ERB rules require some adjustment. We have seen the same in the UK. Those do have a significant cost, and in the case of the UK, that was several hundred million pounds. And of course, being able to completely leverage that for a second program is very beneficial. If we take other very simple examples, even if the numbers are much less still, I mean, they are big numbers, but not hundreds of millions. Safety system, full replication, and 63 million invested in the equipment standards and the tools that those effects you can see effective clearly in the pricing of the different programs. Some practical examples of construction. I'm sure you have seen this happening also in India in your PHWR programs, including also certainly in Kudankulam. So we measure those and we try to keep track of these. So at Hinkley Point, when typically we look at the liner cup floor, it took us 57 days to build and position, and we had a 30% time gain for the second unit, which is just next to Unit 1 at Hinkley Point C. Likewise, if we look at construction of the turbine base slab, the pouring duration for the slab was 18 months. For the first unit, we could be almost twice as fast for the second unit. This goes all the way through the process up until commissioning. To give you another example, when you look at the commissioning of Taishan, between the Unit 1 and Unit 2, it took us 21 months less for Taishan 2 to commission compared to Taishan 1, while Taishan 1, bear in mind, was the very first EPR to be connected to the grid in the world. All of these, we make sure that we integrate as lessons learned, and what is something very specific to EDF, I should have mentioned earlier, is EDF's ability to develop partnerships in the very long term and keep cooperation live and very active over decades. This has been the case in South Africa, where cooperation is still ongoing, with the current steam generator replacement ongoing with the support of EDF at the Coburg plant, and of course a lot of sharing still happening with our Chinese colleagues. So what we do for the generation 3 is we have at the very beginning, already in 2015, set up what we call the EPR Owners Operators Group, where we expect to find all the EPR programs gathered. This is not only a service, but it is also a discipline for us and for our partner colleagues from the different programs, and we obviously hope to add more as we move forward. This is about sharing all about safety matters, so improving safety performance, sharing all good practices, lessons learned in all phases of the project life cycle. There is a network of communication which is very fluid, and people do know each other and meet at least once a year in a full gathering. We are developing currently mutual support, including for spare parts for these programs which are spread across the world. Now, all of that, if we are to look forward, we have to make sure effectively that it rests on a very robust supply chain. The difficulty with the supply chain, in my view, is that these are partly partners, but they also develop their own business. And of course, they have their own decision-making process. And just like we do as integrators of programs and as future owner-operators, they have their own expectations for efficiency, return, and all of that. Now, the key for the whole of programs to effectively be delivered and be delivered efficiently is visibility. And it is what I would say currently we have not been very good at providing. And this is true of all governments around the globe and of all integrators around the globe. Providing visibility is the key to ensure the alignment of the supply chain. For me, this is very much like a magnet. You have to put the magnet in place for the needles to align. Otherwise, you can have as many needles as you want. It will never align. So that's what we need. We need to put the power on so the magnet effectively is active and the needles do align. That's what I call visibility. Now, in France, we are in the stage where the politicians, the government, has fully realized the importance of visibility, and the decision now has been made to build at least 6 EPRs, and government has decided to consider also 8 more. The good news is the 8 more is this time coming from their own suggestion. It's not EDF asking. This is now French government saying maybe we should consider 8 more. And of course, what we see happening in France now is the whole of the supply chain behind EPR, which is a European supply chain, is making investments, actually going through what we call ISO 19443 certification, which is the certification for nuclear. And many of the companies are performing that. To give you a very simple figure, I don't know how many of you know about ISO 19443. I know LNT people know about it because they have been certified recently in the course of the year, and they've done that with us encouraging them. But in the world today, there are the latest figures I've got, they date from last week, there are 161 companies certified with ISO 19443. Out of those 161 companies, 120 are French. Direct visibility. If we aim to provide visibility elsewhere, definite assurance that everybody will align. So this is a very concrete example and I think useful. Now what's interesting in what's happening in Europe is that energy crisis, climate change, necessity to improve energy independence and security of supply. A number of other programs are progressively being confirmed. And as EDF, we are being solicited, so there's no guarantee we'll be building all these, and there is also competition at play. But clearly, EDF's experience, especially in building Generation 3 in Europe, and today EDF is the only one player constructing Generation 3 reactors in Europe. So EDF is solicited and expected to participate in these processes and support these programs. Overall, when we look at what's being accelerated in Europe, and I'm talking about typically the Netherlands having voted in Parliament 5 billion euros program, the Sweden having voted in Parliament a 35 billion euro program, etc., etc. Czech Republic in the middle of a tender process, which we participated in, for up to 4 reactors in the country, and we have many of those currently happening in Europe. Overall, we look at the perspective of 30 EPR projects around the globe. I'm, of course, counting very much on a decision in India for 6 EPR as well, with our partner NPCIL. So this is what we do in our job, in making sure that the EPR can benefit from a very robust supply chain. So our job is to provide our supply chain the visibility of the program they can count on, so that they can decide on the investment, build their business case, and make sure that they can be competitive over time. What we have experienced in Flamanville 3, which was the first of our program in France, is something which maybe you have experienced in some of your first and early programs. It was a single reactor program, and so with no further visibility. So the direct result of that was none of the partnering in company did make specific effort to invest in their processes or in their capabilities to do something very efficient. What they did was something very bespoke, specifically for that plant, for that program, because they didn't have the visibility. What we're seeing happening, without us influencing, is based on this visibility, and for the supply chain, which is used to work with us, which has visibility on our, where we aim to have programs, they do develop their own partnerships in these countries so that they can have, they can see emerge, local partners to make sure that the supply chain at the time of delivery is present and can deliver. And this is exactly what we are looking for. So our job is, on one side, encourage government, partner governments to make decisions. That's what we do in the UK, that's what we do in France, what we do generally in Europe. And based on that, based on our discussion with governments, the best visibility we can provide to the supply chain, we do provide it so that they can make their decisions. To deliver our future programs, we also had to make some very key decisions, one of which is a long process started in 2015, was the restructuring of the French industry, EDF taking leadership of that by decision of the French government, and we went through a process where we have been progressively integrating the capabilities of EDF to support major programs. So we have integrated the engineering capabilities of EDF and Areva, former Areva, within a big engineering entity for the nuclear island, that is Advance. We have had focused, so Areva was several parts, one of which Framatome for nuclear reactor activities, and Framatome has been focusing since then on NSSS and INC. That's really the core of their activity. And for the SMR, we've decided to create a separate entity to integrate the different activities associated to that, because we believe the approach for SMR will be different. Of course, this includes a number of partners, but we do expect this approach to be fruitful, as we hope we can count in big numbers when coming to SMRs. So now these are a few pictures of how much activity, industrial activity, we have accepted to integrate and looking to integrate within EDF. So soon we expect to add to in the integration list what is currently GE, but what are effectively the turbines, the Arabelle turbines, which are today the most performing turbines in the world, and come into to support various power levels. We could put the equivalent names in India for these different companies, for forging, etc. This is as if within EDF you had the capabilities of L&T as well as BHEL as well as Tata included. This is what we have decided to do on our side: integrate so that effectively we can have a bigger outreach and improve and streamline the processes, including in terms of decision making. Now, beyond the integration, we had to also develop a significant number of industrial partnerships. We cannot integrate the full of the supply chain. That would not make sense. That would not be reasonable. So we have started a journey of developing specific major partnerships, the first of which were through engineering. Those Aegis and Adsystem are two big French engineering entities. They're worldwide companies, and they're actually also very well established in India and supporting us today in India as well for the JETAPO program. Bouygues is a major company in France. They're bringing it with us to support the construction activities. All these we would be present with programs, and they have in their approach to systematically develop a partnership and a cooperation with the best local construction company, and so that teaming up can make the whole thing very successful. So, for example, they have teamed up with Lengo in the UK. They have been teaming up with Metrostav, which is the number one in Czech Republic, with Budimex in Poland, and so on. This is a strategic, systematic approach they've adopted. We are developing in the manufacturing scheme some more cooperation. Ansaldo, it's an Italian company. L&T and BHEL, you know about. We do aim to increase those. For systems, we do have Siemens. Of course, we also have internal capabilities through Framatome as well as through GE. Now, going forward, how do we aim to bring value to our partners? So first, through technology. So we have three technologies. We have the EPR, 1600 megawatts, so net, so 1650 megawatt under design. We have an adaptation of that at 1200 megawatt, where constraints, typically cooling capacity constraints or grid constraints. And we have the new kid in the block, which is new wired at 340 megawatt, which is aimed at replacing aging coal plants. This is how we've aimed the plant to be positioned in the market. EPR I will not go through this. Most powerful reactor in the globe, 4-loop configuration, generation 3+, very high level of availability, designed for 60 years, but probably can live for much more. Fully digital. Happy to answer questions on that if needed. So EPR 1200 is directly derived from the big EPR, except that it has one less loop and it's got a smaller core. So what we make sure we do is that we replicate fully what we know now how to do well in the EPR 1200. So it's not a new design. It uses exactly the same steam generators. It uses exactly the same safety trains. It uses exactly the same INC, and so on and so forth. We try to invent as least as we can to make sure that replicability is the motto. For NEWARD, we have gone through a different approach. So NEWARD, this is our SMR. We have gone through a different approach. So this is composed of 2 modules of a 170 megawatt reactor. Each of these reactors generates 540 megawatt thermal. And for NEWARD, while we have taken a classic approach of pressurized water reactor, because we know the principle works, this is our experience. So this is a generation 3 reactor. This reactor is, this plant is supposed to be fully passive in terms of safety. It's got a few innovations inside, especially compact steam generators. The difference between the two, between EPR family design and NEWARD design, is NEWARD is designed to be fully modular, so meaning modules manufactured essentially off-site and minimum on-site construction and assembly. Of course, concrete, all of that will have to be poured on site, and it's clear that civil works is the one piece that in nuclear you cannot avoid, and you have to do really on site, but the rest of it, the full of it, we expect to do from factories, and this is what should bring the numbers and the cost down for NEWARD. I will not go through this, but these are the core elements which support the all our designs. This is true for the EPR family as well as for NEWARD. You will find a number of things which are similar to what is done in India, except that our codes and standards are essentially European, of course. Long-term partnership, I think I developed this idea earlier, but this is really at the heart of, if I had to define EDF, I think first and foremost we are a utility and an operator of nuclear power plants before being a designer. So we design plants to operate them. We do not design plants to sell them, we design plants to operate them ourselves. So when we do perform the design work, we do have in mind the operation directly, and actually our operator in EDF would be challenging the design each and every day. And probably for people in NPCL and who perform design work, you know that it is tough always facing the operator.
Mr. Vakis, it will be better if we can conclude in the next 5 minutes.
Okay, thank you very much. In our value proposition, we talked about reactors, safety standard, I think that's now our experience in Europe, that's what we bring, and that's what we want to share. We have the full support of the French government. I didn't mention it, but EDF is today 100% owned by the French state. And this ensures good alignment of interest between EDF and up until the top of the French government. As I explained, we bring together with us a full integrated industrial capacities and to develop partnerships. This is key, especially if we want to project ourselves in many geographies. And we do promote actively industrial cooperation and localization. Training is something which is embedded with what we bring and propose. We do start these very, very early, and we have second-to-none training capabilities in the world. Now, I could have developed the case for New World in India as well, but I chose to do it with Jaitapur, as this is a very concrete work that we're doing with Mr. Jay Krishnan for many years now. I'm yet to see in your credentials Jaitapur, because I've seen that Kudankulam and all of that, but soon we can add Jaitapur. Thank you. Hopefully, Mr. Jay Krishnan, I hope we'll be able to do that together. Now, many good things about Jaitapur. It's 10 megawatts on a single site. If we manage to get Jaitapur started, clearly I think that opens a realm of opportunity for India, acceleration of decarbonization, and essentially a realm of opportunities for the industry. I do believe that if Jaitapur can go through the decision process in India and be approved, India will not just stop at Jaitapur for EPRs. I think EPRs will have a strong future in India if Jaitapur becomes a reality. Now, where am I? Here. So this is, in a nutshell, where we are today. So this is the status of the program and what it can bring, how much power it builds in numbers, and how million tons of CO2 we can avoid. Sadly, today, we do not put any value, money value in front of that. We should, because effectively, this is the value of the future. And whatever we avoid is effectively money we can save from, avoiding other disasters somewhere else. As at today, for manufacturing and engineering, we are at the level of 20-25% localization in India, which we believe is not sufficient. Our objective is to increase that significantly. If we include construction, this number would be 35 to 40%, but we believe we can bring the overall number to something close to 70% in India without any difficulty. So this is, I think, an area where we will be working a lot in the coming months and years. Of course, there is a very strong support from the governments. What is not said there is, and why is it decided as a program, two aspects which are developed here. Number one, we have to make sure we completely de-risk all matters related to compliance, and that is ongoing today between EDF and NPCIL. And second, we have to improve the competitiveness of the overall program, and this will be at the heart of the decision, and this is also something that we aim to improve in the coming months. Key action to allow that to happen, to improve the number, is improving localization, given how competitive and efficient the Indian industry can be. This is the overall landscape of companies supporting EDF and our supply chain. You can probably see there a number of entities we have been starting working with and will continue to work with to ensure that we can make the delivery cost-effective for Jaitapur. I think this could have its own specific presentation related to localization. We have a very robust process for that. What is required effectively today is a decision, strong support from government to ensure that we can go through and that all the Indian companies interested in Jaitapur can engage and go through the selection process. We have launched not long ago our new offices in Navi Mumbai, and we are to launch early next year an engineering platform in India. This is to support not only Jaitapur but also our other EPR programs in the globe. We do have a lot of expectation support for our worldwide programs. So this is our commitment for the success of Jaitapur. This could be for any program around the globe, but of course being in India and here today, NPCILs, this is what we should be focusing on. Make sure that we have a robust and sovereign Indian nuclear supply chain supporting the program. We commit to make NPCIL benefit from all the synergies and learnings from our program, and we do have a lot of expectations in the pipe to come. Long-term support with the benefit of being part of a very strong owner-operators group, and of course the benefit of our values which have led us to who we are today, with respect, excellence, solidarity, and responsibility. I thank you very much for your attention.